independent variable. Multiple regression model. So before we start with multiple regression and chi-square test utilizing SPSS and the data set, do you remember that we just tried to run with the scatter plot the other day? It was more of an ordinal scale from the 0 to 4 scale, and on scale of 7. So when you try to run, it looks like it's still static, by line, but because it just it is still sort of ordinal scale, it doesn't have that much of the changes across a different 4 different scale or 7 different scale. So what I did exactly the same way for really more numeric or interval variables. Just this is how it showed. Okay, so let me share. Let's share screen here. Okay. So when I will show you here. So this is the variable we're going to play with today for the regression model, multiple regression test. But when we ran, okay, the age, they ask people, what is the age, your age? And also mostly from 18 years old, and then up to 89. And then anything over 89 as the next category. So when we put large sample size, still, of course, your ideology is from 1 to 10. So it still had some sort of line. But as I ask you guys to do, in order to show more of just to look like the data and just to see the pattern, this is when I select only 5% of the data. Okay, it's still a little kind of chunky and clustered together too much. This is 3% and this is 1%. You can see, okay? So when we are dealing with a more of an interval scale, in other words, more numeric variable, so it is from not 1 to 5 or 1 to 7, maybe 1 to 100. So more numeric scale, and you limit the number of the sample size between 30, sometimes you show that very well, to maximum 20 sample size. You select random sample and run. If you run this scatter plot, you will see some pattern. Okay, so it is negatively, you see some patterns rather than just cluster them all together as some dots in a square thing. So you can avoid that kind of a presentation. That's how, if you wanted to use, that's how you can do that. All right. But actually, Rahul the other day asked me, do I need to run some scatter plot? No, there's no way you can run for scatter plot for variable description. Scatter plot, again, here you need 2 different variable to see the relationship, right? But the variable description and variable, your individual variable, it's as independent variable and dependent variable. You need to run each separate descriptive statistics. There's no way you're gonna do any scatter plots like that, okay? So if you wanted to run scatter plot for your main analysis later, if your most of the variables are interval and it is a more numeric variable, you can do that, of course, but not at this stage for a variable description. Is that clear? Okay, cool. All right, so let me actually show you, I played it with, again, 2024 data set. It's still new to me, so I'm still looking all over and see what variable I'm gonna use for, testing and show you and demonstrate how we can run those data, with variables from the newer 2024 data. So I looked up, and let's actually use age, multiple regression, and simple regression. Both independent and dependent variables are interval scaled. But simple regression model had only has only one independent variable. Multiple regression model had more than one, at least two different independent variables. But all the scales of measurement for the basic foundational basic model of multiple regression and simple regression, they should be all integer, all numerical variable. So what about using age and gender? I'm sorry, age and how old are you? It's all integer scale, from age, since this is the survey done for for the participant over age 18 up to all the way up. So from 18 to like closer to 100. And then number of years of education. So from 1 year of education, 2 years of education, so number of years education. So mostly, most common way you can get up to like it, in terms of the length of the years of education, it's mostly about 20. If you complete masters and after masters and PhDs together, it's about 20 some years of education. So the number of the number of years of the education from 0 to 20. So the both are integer scaled variable. And then it's not purely integer either, but depending on the age and depending on the education, how your ideology really changes over time. Because current administration really kind of picking on higher education, and higher education tend to make people more liberal. Okay, let's see whether it is true. Actually, the national data found that it's true. Okay, but it's not only education there. There are multiple other factors that should be considered together. But just let's see, your age matters for your ideology. Okay, as you are getting older, you're more likely to be conservative. That's been for a while, but just with more of the current and timely matter, I want to measure whether education as an additional variable to see where their ideology lies on a scale of 1 to, I think, 1 to 10 or 0 to 10. That was the variable we used before, right? Excuse me. Okay, so here we're gonna use left and right. So 299 as a dependent variable. So all these are variables, as I mentioned, that those ordinal scale variable on a scale of 5, 4, 7, and 10, you can decide whether you can use that as the way it is as a different category. So then you can treat that as a nominal variable, but as long as it behaves like a numerical variables, you can use as integer variable. It requires some of the theoretical background and understanding of those variables, okay? So now putting age and the years of education and how they affect people's level of the ideology. That's what you're gonna just run. Again, I will go over in a minute, but the last part of your project due tonight, you need to run descriptive statistics for each variable you use, okay? But as I mentioned, that the best way is for each variable, run descriptive statistics separately, but think about it, regression model, multiple regression model, all variables will be numeric, all variables will be required to be integer scaled. So we can put all those variables together to run descriptive statistics together, okay? So in order to make sure it's clean or not, let's go to descriptive statistics and frequencies. And then what I need to put it here, reset. Okay, age. And the second one was education. Oops. And then The dependent variable we're thinking is left and right. So I taught you how to use some trick. This is a really big and long data. So you click anywhere in the list of the variable, you type first three letters and first three numbers, it will go to that particular variable right away rather than scrolling up and down. So that's some trick if you want to use. So let's just check whether they are clean or not. Leave frequency table as a check, and then statistics there. This is a descriptive statistics. Descriptive statistics require central tendency and variability. These are all numeric variables. And so you can find the mean, median, mode, no problem. And since we have a mean value and we have a smallest and largest value, you can check all these variability values, okay, tests. And on SPSS, it is listed as under dispersion. Intuitively makes sense, right? So, and then let's say continue and okay. Then let's see whether it's clean. So age, mean age is 50, highest education, years of education around the 14 years. And then left and right, it's from 10, scale of 10, around the 5. So it's a more of a leaning to conservative because here, let's see, 0 is left, 10 is right, right? And then you see it's a clean, yes. Years of education from first grade all the way to how many years of college and higher education you have, right? It's all clean. Missing cases are coded as missing. The ages also, they are valid. So this is, you can report descriptive statistics and frequency tables just to confirm your variable is clean. Then what you're gonna do, now let's do main analysis. Okay, but for you guys doing the main analysis, we can explore, just work together. And I walk through each stage with you. So actual main test is not due until the last week of the semester. All right. So let's go to analyze to run multiple regression. So go to analyze and then go to, again, regression, where we went to run simple regression model with one individual, one independent variable, and then go to the same place as a linear. Okay, we still want to predict a linear relationship together, right? So right here, we wanted to use ideology as a dependent variable this time. Left or right as a dependent variable, and then age as you're gonna put here as a block 1 and block 2. Sometimes you just to have a more of the panel way, like a first stage and second stage of the analysis as well. But here we're gonna repeat what we covered from Tuesday class as a multiple regression model. All right, so the basic form of a multiple regression model, not just having some variant of the regression model, and age, and then the next one was education. So put that together. All right, and then just let's run. Mostly by default, they will provide you all any statistical analysis you request to run from the statistical software. They will provide you all numerical information, the values you need for the result of the statistical analysis. So you can simply run, okay, and they will provide you. But if there's other things you wanted to run as additionally, the descriptive, or if you want to run plot, and you can just play with it. Last class session we did it, right? But just I want to leave it as simple it is, and then let's go to okay. And now, the big differences between correlations and regression slope is correlation slope is a standardized slope. Okay. And then correlation test and simple regression model, we use a small letter r because that represent how much one variable explain the other variable. But as what we discussed in last class session on Tuesday, it is a collection of all independent variable together, how much they explain. So it's R squared value to capital letter R. So two independent variables, age and education together, they explain about 3% of the variations and values for ideology. Seems like it's small, but let's look at the coefficient table. Coefficient table, UCT test. This is the test for whether each individual independent variable, they are statistically significant or not. And then I explain from the Tuesday class when we go over multiple regression model. Regression model had two different tests. One, is it a t-test for individual slope, and although it said ANOVA, it's not ANOVA test, it's F test because they use F distribution. So honestly, SPSS software, they should change it, this term not to mislead the people. Okay, but it's F test as you see here. That really confirmed that the equation model from this regression model, it is statistically significant. That's what it is. So let's get back to the interpretation. So right here, beta, it's a slope, is right here. Before you confirm whether it is statistically significant or not, even do not try to make any of the judgment with the slope itself. Okay. So when you go to t value and p value for age, it is less than, the p value is less than 0.05 and 0.01 for sure. That means it is statistically significant. So slope is not zero or flat. So instead, it has the somewhat significant t value. Okay, we know how to read the t distribution table, but again, I don't expect you use the actual physical distribution table. But it confirmed that it is statistically significant. Age explain ideology. How much? And as one of the beauty of regression model is we have a control power, and also using the unit of the measurement, we can make a much more informative interpretation. So here, the slopes value is a 0.016, okay? And it is a positive, it is a statistically significant. Controlling education, age is important indicators for ideology. How much? So you can use the actual unit. When you are aged by one additional year, your political ideology and conservative, your ideology, you are more likely to be conservative, more likely to move to conservative spectrum on a scale of 10. How much? By 0.016. So if you aged by one more year, you are more likely to be conservative by 0.016 on a scale of 10. That's what you can say out of this. Isn't that neat? What about education? Again, when you look at it, oh, it's negative. So that means you're more educated and it's gonna be less conservative, and in other words, more liberal. So maybe in a way, Trump administration argued that higher education make people more liberal. Maybe true based on this analysis. So it is statistically significant, and you can go back to the B and slope, and you can say that and interpret it. If you have one additional years of education, you are more likely to be liberal by 0.115 on a scale of 10. Or you are less likely to be conservative by 0.115 on a scale of 10. So depending on how you want to just wording and just write up your sentences for the result. That's what you can say for individual independent variable. And then the beauty of regression model is you can come up with um, equation model, right? So I will just go slowly rather than just back and forth with the whiteboard. So you can write up how, I don't know, I can just use some empty space here, but let's try. Y is a dependent variable. Y means its ideology equals alpha value. Where is the baseline? When we don't consider, regardless of age and education, still people are, the baseline of ideology for people, it's going to be 6.156. So y equals alpha value, which is 6.156. Now plus 0.016 x1, which is a variable 1, which is age. And then the next is negative 0.115, and x2 is a variable 2, which is education. That's the equation model you can write up. So once you have that, the beauty of this multiple regression equation model is you can use it for later. As long as you can plug in number, you can find the dependent variable's value. So that equation model, whether it is statistically significant or not, that can be determined by F-test here. So F-test here, almost 35 and 36, and the p-value is less than 0.05 and 0.01. It really confirmed that, yes, that equation model, it is statistically significant. So these independent variables together explain something about significantly, something about ideology. That's interpretation you can provide. Isn't that wonderful? Okay. But as I just kind of repeating it, but if you keep adding your independent variables, of course, your equation model itself will be significant because with any additional independent variable, your R square value only goes up. But as I mentioned, that you need to be efficient. If you have a 30, 40 different independent variables, but may it explain about 30%. But if you have only 5 different independent variable, but it explain maybe 25%. Then statisticians in academia, they want to go with the lower R value, but it's more effective. Using only 5 independent variables predict something about dependent variable, that is more effective rather than, oh, everything matters. You put 100 different variables into the model. It doesn't really make sense. So you need to decide up to what point, up to what levels of R squared value is significantly increased by additional independent variables for more reliable and theoretically important equation model. Okay, so this is multiple regression model that we ran. And then now let's run chi-square test. As what you see and what we saw, statistics roadmap, it's our first time. What if we ended up with both independent and dependent variable? They're all categorical. They're all nominal. Okay. Then your option is a chi-square test. So it's a less robust test, but at least it detects whether between two different categorical variables and two different nominal variables, there are associations or not. Okay. So for that, let's use, instead of ideology, party ID. Okay, party ID. And then what about, as what we use as the example, what about the gender? Okay, so gender and party ID, and we oftentimes predict that males are more likely to be associated or affiliated with the Republican Party, and females are more likely to be affiliated with the Democratic Party. Let's see whether there's some association with the national data. So where you need to go to do, again, let's just see whether these variables are clean. This is what we do for this stage of a project. So now let's go to same place and descriptive statistics and frequency. And then now we want to run party ID with How do you? Okay. So again, I'm able to put both the variable at the same time. Both are categorical. But if you have a numeric variable and categorical variable, never really put them together because you should run different statistics, right? So since these are all nominal categorical variable, only central tendency you can report is mode. But none of those variability tests is possible because we cannot quantify these values for meaningful numerical values. So just mode, that's what you can report for part of a descriptive value and continue. And let's see whether it's a clean. All right, so party ID, although it's a sort of ordinal scale, and that's clean, and a male and female, that's clean. So we confirm that. And descriptive statistics show that only the valid information from categorical variables mode. So that's what you need. So done for descriptive statistics. And then now, in order to run chi-square test, you should go to analyze. And it's what I explained from Tuesday class. Chi-square test only try to detect whether it is associated or not. It's still part of, makes sense. Like in many statisticians, I think, okay, where we should have put chi-square test. They put different, kind of a chi-square and for different purpose, but the basic form of chi-square test we ran from the book, we learned from the textbook. You go to descriptive stat under analyze, again, descriptive statistics, and then all the way down to, can you see cross tab? Cross tab means alternative way, it's a contingency table. Everything about chi-square, it is about the contingency table. All right. Then you have this pop-up window. And there are sort of agreement unless you just identify which is your independent variable, which is your dependent variable. Sometimes the list of variable we wanted to put in the table, you can identify with that. But unless you explain it, in contingency table, usually the column variables are dependent variable, okay? And row variables are independent variable. Okay, so without explaining it, if you make the contingency table, the cross-tab table, scholars, they understand, oh, these column variables are the dependent variables they are looking at, and most of the row variables are independent variable. But if you want to just flip that, of course you can do that. Just explain it. Otherwise, people just think the conventional way of column as a dependent, row variable as independent variable. So let's go with party ID. But of course, the gender is more likely to be independent variable based on our theoretical understanding. But you can go vice versa too. And let's see, sex is independent variable and party ID is a dependent variable. Okay, so here, just look at closely. In order to run chi-square test, you should go to statistics. Okay, then there are list of the tests you can run, and some are kind of familiar, some are not. But can you see chi-squared test? Okay. You can check that. But actually, exact and correct name of a chi-squared test is not chi-square, it's a chi-squared test because it's squared values of each cell. So the actual correct name is chi-squared test, all right? Should be D at the end. All right, and you check that. And then the necessary step for us to do, go to cell, okay, before you run. Most of the time, you don't need to do all additional stuff, but this is still part of a contingency table. We need to ask what we need. And as what we discussed on Tuesday class, so one of the requirement for chi-square test is that we wanted to have a minimum sample size in order to run, in order to make sure this test is valid. In order to have that, the criteria is each cell should have at least 5 expected frequencies. Okay, so just in order to check that, uh, beyond default value to check, observe the count from data, find report the expected count to make sure it is at least a 5. And then, as I mentioned, that it's just like a limited information. Chi-square test itself, it just provide information whether those two categorical variables are associated or not. Then people wanted to know how they are associated. Although it's not strength, but there should be some pattern. What you can use to provide some sort of a pattern, usually by percentage. Okay. And usually what you need will be the row percentage, okay? But in case sometimes it's useful, let's report the columns, for percentage as well. Once we have that, you will see what I'm talking about here. So continue, and then goes back to main pop-up window, and then let's select that. So chi-square test contingency table really show you a whole lot of count means it's observed frequency. Expected count, that's how they calculate by column total multiplied by row total divided by total of total. Okay, so that's the expected one. So we compare observed frequency with expected frequency if there are significant differences that are different from independence of these two variables. That means they detect dependency. That means it's an association. So just let's check whether it meet minimum requirement with at least 5 expected frequencies. All the way. It's much larger. So yes, it passed the minimum fine line of a requirement. So all expected frequencies in each cell is over 5. That's good. So do not try to make any of these numbers, try to read it to make sense before you check the chi-square value. Chi-square value 36 and look at the p-value. The less than 0.05 and 0.01, so that means it is statistically significant that gender is related to their party affiliation. It was confirmed. And then now, in order to explain more informative information, you can go to pattern. So males are like using the row percentage. Males are more likely to be a little bit of a more strong. Um, yeah, females are a little bit more strong Democrat and a little bit of not very strong Democrat. And males are, as what expected, a little bit more, a larger percentage of the strong Republican, but not strong, but still more likely to be Republican. But it's the same here. But as what you see, it is very much ordinary, and that's just kind of a detailed categories. But if you want to see this statistical significance with a better interpretation, you can merge sometimes different, as what we did, all Democrat, Independent, and Republican together. So let's see, roughly, let's add that. Democrat, strong or weak, but still Democrat. Let's combine the male percentage. It's going to be about 15 and 9. It's going to be 24.5, right? So about 24% and 25% of males are likely to be Democrat. Let's look at the female. So it's going to be 17 and 13. It's going to be 30. 0.5%, so 31%. So there are quite more significance in their, the kind of a division between male and female for Democrat Party affiliation. What about the Republican? Let's add those strong and weak Republican Party affiliated percentage. So it's gonna be 11.6 and 15.4. So it's gonna be 27% for the male. And then what about female? It's gonna be 24. Okay, so it seems like it's not that much, but with this large sample size, sometimes the 2-3% is a big deal. It really comes from that. It is statistically significant, right? So that's chi-square test. All right. So then the rest of the time, we're gonna run individual project. Okay, individual project. Um, so I can go over. Maybe you share your, uh, screen and your data, and just to jump around and show me. And if you want me to look at your document before your submission, whatever you want to do, let's just spend time for your individual project. Okay. So let me actually stop recording because it's your personal project.